video, we're going to do some math as per special request from ZAK HALIK. Last math lesson I saw him struggle with some probability questions. So I decided that, I might as well, instead of explaining it all to him, might as well make a video so that Kobe can see it. And maybe you guys also need some questions with probability. So we're going to start from question number 1. Sigma chooses between 3 options. Strategize 40%, adapt 50%, or withdraw 10%. Calculate the probability that Sigma will either strategize or adapt. As you can see, there's a made of questions because Sigmas never withdraw. But we're going to go with it as clearly this was written by a female. Alright, anyways. So strategize is 40%. That means 40% equals 0.4. That's because 100% equals to 1 and 0% equals to 0. I hope we'll know that. That's the most basic. So 40% is 0.4. That means that 50% is obviously 0.5 and 10% is 0.1. So the question is the probability that Sigma will either strategize or adapt. So strategize is 0.4 and adapt is 0.5. That means that probability of X equals strategize plus adapt. So in total, strategize plus adapt is 0.4 plus 0.5 equals 0.9. As simple as that. Alternative solution would be to, as we know, the probability of withdrawal is 0.1. So we'll let X equals withdrawal. In that case, probability of X equals 0.1. And probability of Y equals 1 minus X, minus probability of X, which goes to 1 minus 0.1, which gives us 0.9. Just as simple as that. So the probability that Sigma will either strategize or adapt is 0.9, also 90%. Either way is correct. However, as advice from pro, keep it as a decimal. It's a lot easier because in case you need to work with numbers with this number after, you won't have to convert it back from percent. So just keep it as a decimal unless the question requires you to obviously have it in the percentage. Alright, question number 2. Tommy Shelby flips a coin 3 times. What's the probability of getting at least 1 head? So, coin flip. We'll say A equals heads. Right? That means probability of A. Probability of A equals 0.5, aka 50%, because coin can either be heads or tails. So getting at least 1 head. What are the possible options of a coin flip 3 times? So it's either heads, 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 tails, heads, 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 tails, tails, heads, heads, as well as heads, tails, 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 heads, tails, and tails, tails, heads. And the last one is tails, tails, tails. So as you can see in total we have 1, 2, 3, 4, 5, 6, 7, 8. 8 possible outcomes of flipping a coin 3 times. So we need the ones with at least 1 head. These are all of those except for the tails, 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 because tails, tails, tails is the only one that doesn't have at least 1 head. So we could calculate the probability of getting the or none of those. However, the much simpler way is to just calculate the probability of getting 3 tails and then subtract that from 1. So probability of getting tails, tails, tails equals 0.5, that's one flip, times 0.5 times 0.5. Also equals as 0.5 cubed. That equals to 0.125. Common knowledge, you know, if you don't know that, come on now. 0.125, you can use a calculator because the exam will be tech active, so that's completely fine if you need it. So yeah, that's 0.125 is the probability of getting 3 tails in a row. So it means the probability of getting at least 1 head is 1 minus 0.125, which equals to 0.875, or 87.5% of getting at least 1 head. Hope that helps. Question 3. Patrick Bateman has one choice among 5 tools with equal probability. What's the probability of he gets either a knife or an axe? So we have 5 tools with equal probability. So all those 5 tools probabilities should add up to 100% or 1. So that means 1 tool, so 5 tools equals 1. That means 1 tool equals 1 divided by 5. Simple rearrangement. So we move this there, so we divide. That means we have 1 left here. So 1 tool probability is 1 over 5, also known as 0.2, aka 20%. So that means a knife probability is 0.2 and axe probability is 0.2. That means we just do 0.2 plus 0.2 equals 0.4%. 0.4, also known as 40%. Simple. Another solution would just be to know that we have 5 tools and we need 2 of them. So it's just 2 out of 5 because the tools have equal probability. If the probabilities were different for each tool, then it would have been different, but in this is the simplest case. So as I can understand, you know. Question 4. Shelby Company takes on 3 ventures. Each has 70% chance of success. What's the probability all 3 ventures succeed? Another simple one, probability of 3 ventures. So 1 venture equals 70%, also aka 0.7. So that means 3 ventures is, as we've done in this previous case, is 0.7 times 0.7 times 0.7. Also 0.7 cubed. I'm not actually sure what that equals to. I haven't done the math yet. 0.7 cubed. That would be 0.343. Okay, 34.3% chance. That's not too bad. 3 ventures, you know. Alright, question 5. In a special deck, there are 52 cards, 13 of each suit. What's the probability of drawing a heart? I think this one is a bit way too simple. So 13 of each, that's 1 over 4. I'm not actually sure what the complexity of the question is because hearts is always 1/4 of the deck, and 13 times 4 adds up to 52. So yeah, 1/4, 25%. I think this is just to give us some rest before the real question, hard questions start. All right, question 6. Sigma has a list of tasks with probabilities 0.3, 0.2, and 0.5 of choosing them respectively. What's the probability Sigma chooses either first or the third task? 0.3 times, so that's the first or the third. It's not times, but it's plus. If it was to be times, times we use when it's consecutive. So the probability of him choosing first and then the third is 0.3 times 0.5. But however, we're just adding probabilities because it's just either or. So it's not times, it's plus. So 0.3 plus 0.5 equals 0.8. Simple as 80%. Question 7. Tommy has a 30% chance of winning a duel against an opponent. If he duels 3 different opponents, what's the probability he wins at least 1 duel? So this is similar to the question coin, except this time we're gonna have a different. It's not a 50% chance. So 3 different opponents. For this scenario, we're gonna have to use the probability table. So let X equals the number of times he wins at least 1 duel. All right? No, number of duels won. So out of 3 duels, what are the possibilities of him winning? How many duels? So he can either lose all of them, win 1, win 2, win 3. So we'll now have 4 different options here. This is called a discrete random variable because it can only take on 4 different numbers. It's not an infinite amount of numbers. That's why it's discrete. So table of X and probability that X equals to X. So this is the way to write that probability that X happens, pretty much. So simple table. 0, 1, 2, 3. In what scenario would he have 0 duels won? In case he loses. This question also is pretty dumb because Tommy Shelby never dies. He's another fellow Sigma. I would say the chances of him should be 99.99999, but no, that's fine. So 30% chance, the only possible way for him to have 0 wins is to he loses all 3 times. Win equals 30% equals 0.3. But as he can either win or lose, that means loss has to be the remaining. So 1 minus 0.3. So 0.7. So he has a 70% chance of losing. So that means losing 3 times in a row would be 0.7 times 0.7 times 0.7, aka 0.7 cubed, which as we know is 0.343. So we'll write this down here. 0.343. Now, 1 time he won. What are the possibilities of him winning 1 time? So either loses, wins. Loses, wins, loses. Wins, loses. So, possibility of him doing that. That's 0.7, he loses first time, times 0.7, loses the second time, times 0.3 because he won. That would give us 0.147% chance for 1 of the probabilities that he loses, wins once. But because it's not 1 of those, but it's 3, we times this number by 3, which gives us 0.441. So we'll write this down here. Now, probability that he wins twice. So it's either lost 1-1, one lost 1, or 1-1 lost. Same principle here, 0.7 times 0.3 times 0.3. It's important here to not mix up the probabilities of which is which, so you gotta remember that loss is 0.7 and the win is 0.3. So this would give us 0.063 probability. Same scenario, it's only 3 possible combinations of that, so we just times it by 3. That gives us 0.189. 0.189. And the chance that he wins 3 times is same as loses 3 times. So you can only win 3 times in one possible scenario. Win, 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 which equals to 0.3 times 0.3 times 0.3, aka 0.3 cubed. That is 0.027. Another way to do it is once you found these three, we can just do 1 minus all three of those, which would equal to this number, because that's the last possible combination option. Like, because unless he wins 0, if he doesn't win 0, 1, or 2 times, he has to win 3 times, because winning 4 times, you can't win 4 times in 3 duels. That's impossible. So now we know the probabilities of him winning each times. So wins at least 1 duel. So probability x at least 1. So it's x is more or equal than 1. What does it give us? That's 1, 2, and 3. So it's as simple as 0.441 plus 0.189 plus 0.027 equals to 0.657. So a 65.7% chance, which sounds reasonable considering he has a good odds against for winning. Question 8 out of 10. By the way, Zach, let me know if you don't understand anything. I try to make it as detailed as possible, but these questions, I made them as simple as I can on purpose because I know that you struggle with year 11 stuff as right now, and adding probability is already pretty hard for you. So I decided to go with the very, very basics. So I'm not really using any formulas here or anything, just so you can get the most basic understanding of probability is. So just everyone leave down the comments if you don't understand anything. I will happily make another video explaining this. Anyways, back to business. Question 8. A random draw from a bag containing 4 types of Peaky Blinder badges. 10 Tommy, 5 Arthur, 3 Polly, rest in peace Polly, and 2 Ada badges. What's the probability of drawing a Polly badge? So how many badges do I have in total? 10 Tommy, plus 5 Arthur, plus 3 Polly, plus 2 Ada. That means that is a total of 20 badges. Polly badge, we have 3 of them. So it means it's 3 out of 20, which equals to 0.15, which equals to 15% chance. Very simple. Pro tip, on your exam, you will be able to leave it as 3 over 20. You won't have to convert it to 0.15 because that's also a ratio. As a matter of fact, leaving it as 320 is better because 3 over 20 is, you can convert it to a decimal without rounding up. But however, if you have like 165 over 17 or something like that, or like 17 over 165, you can't convert that to decimal without rounding down or rounding up. So if you want to make your answer as exact as possible, just leave it as a decimal. Not a decimal, as a ratio, so you'll save extra time as well. Question 9. Sigma makes 4 attempts to solve a problem, each with an accurate success rate of 25%. What's the probability Sigma succeeds exactly twice? 4 attempts to solve a problem, so either success or failure. So, probability to do it exactly twice. This question is worded weirdly. Solve a problem. It's a problem, so that would assume that when he solves it once, then the problem's solved, so he wouldn't need any more attempts. But we'll just assume that there's different problems each time. So what are the possible options? It's all the same thing again. For 2, it's either fail, fail, success, success, fail, success, fail, success, success, fail, fail, success, or success, fail, success, success, fail. success, fail, success, fail. And I think that's it actually. Oh, I know there should be 6. So yeah, success, success, fail, fail. Okay, so these are all the possible options, and the principle is really simple. 25% rate for success. That means fail is 0.75. So what we'll do is we'll calculate for one of those. So it's 0.25 times 0.25 times 0.75 times 0.75. Which gives us a chance of 0.035. Something. We'll just round it off for now. And because it's 6 of them, we times it by 6, which gives us 0.2109. So I'll just leave it as that, 0.21, which is a 21% chance to solve exactly twice. So the reason that we times it by 6 is because the multiplication, you can rearrange it and it wouldn't change the answer. So because in each of those outcomes, there's 2 failures and 2 successes, all that changes is the arrangement. So for this one, it would be 0.25 times 0.75 times 0.25 times 0.75. So the numbers don't actually change, it's just the arrangement. So this one went here, and this one went here, this one went here. So the number will still be exactly the same for all of those. So we can just times it all by 6 instead of wasting our time, which is the beauty of math that, while the dumb people like, Tyler would be counting all of those one by one and add them up together. And, by the time you do that, your exam time is going to run out. You really can't afford it on a methods exam. Yeah, that's the question. Last question, guys. I think this might be the hardest one, yeah. In a Peaky Blinder trivia game, a spinner has 8 sections, with each representing a different character. What probability of landing either Tommy or Arthur? Okay, that's also really simple. Zach, I hope you understand this because, I am planning to teach you later on more complex stuff. So stay tuned for that, guys. Got some more probability questions, but next lesson will be about standard deviation, stuff like that. So, get ready for it. Trivia game, 8 sections. Spinner always has the exact same amount of sections, so they're all equal in size. So we're either Tommy or Arthur, so that's just 2 over 8, or 1 over 4, 25%. That's it. So the probability of landing either Tommy or Arthur is 25%. So you guys, this was the introduction video into the probability. So we've gone over the most basic questions, just a simple addition, multiplication. Next lesson, we'll go further into it. We're going to go through conditional probability. So things like probability of A happening when B happened. If you're smart of you, the smart of you will know that it's actually equals to probability of intersection between A and B over probability of B. But that's just a teaser. I'm not going to go into details. Stay tuned for next lesson, and subscribe to Alako channel and also my channel. It'll be linked in the description. If you want more math lessons, please subscribe, and